In today's session, let we learn about Unit 5, Memories and Analysis of Asynchronous Sequential Logical Circuits. So let me first move to your introduction of our memory devices, classification of memory devices, how to define a memory device. So let me start with the block diagram of memory device. So memory device is a collection of your binary cells where it can hold the binary or the digital data. So it can store either a 0 or in a 1. So based on your number of data bus length, so it can hold n number of data bus. So now here I have given a 2 power n into m. So this is the order of the memory device where it can have total number of memory locations at 2 power n, and in each location it can hold the data of your n data bits. Now, so here not to select one of the memory location, we have to use the address decoder, and to select your one of the output from this address decoder, we have to transfer n data bits. So these n data bits would select one of the memory location through this address decoder. So now if the n data bits all are 0, the first memory location is selected, and if your address bus n bits are logical ones, so then the last, which is the last memory location 2 power n minus 1 is located or it is selected. Based on your control signals, read or write, you can perform or you can enter a new data into the selected memory location. So that data part will be provided through this data bus. So the devices which are input devices will transfer those data bits through this data bus, and it will be loaded into the particular memory location using your address bus. In the same manner, when I wanted to retrieve the data from the memory location, first I need to select the particular memory location from where I need to select the data through this address bus. I will select that memory location, and upon selecting that memory location, so then the data must be retrieved from your memory through the data bus, and it will be transferred to the output devices. So in your processing the data, so in processing your binary data in a processor, so first it has to be transferred the data from your memory into the registers, processor registers. Upon processing the data, the intermediate results or the final results must be loaded back into the memory location. So using this database, so you can take out the data or you can enter your data into the memory unit. Now, so here I have given 3 examples of your memory. So the order of the memory which are defined with the number of address lines as well as your number of data bits, where it can hold each memory location can hold your number of data bits. Based on this second number is dependent. The first number denotes number of memory locations, second number denotes the number of data bits on each memory location. So if it is first number is 8, so you require the address decoder should have your 3 data bits, and those, so then only it will be, so 2 cubed is equal to 8. So hence we require that the address bus inputs must be, so which you have denoted with A1, A2, A2, A1 and A0. So 3 address bits must be needed in order to locate your 8 number of memory location, where in each location you can hold the data bits are 8 data bits. Hence the database width must be denoted as D0 to D7. So total 8 bits it can hold in each memory location. So to select one of the memory location, we require 3 data, so 3 address bits, and upon selecting the memory, so when you wanted to enter the data, so these 8 data bits, so this 8 data bus, so that data bus of 8 bits are loaded into the memory, or that 8 bits which are already stored must be retrieved from the memory through a data bus. The second example I have given 16 by 4, where here in this location, in this memory, so you can have your 16 locations. So to select one of the memory location, we require so 4 number of address bits. So now as here 16 is written as 2 power 4. So 4 address bits are required, which are denoted as A3, A2, A1, A0. So when you transfer through these address bits, so your binary bits, one of the memory location is selected. If all bits are 0, the first memory location is selected. If all bits are 1, so then the last memory location is selected. So now upon selecting that, so by enabling your control input either a read or your a write, you can enter a new data into that selected memory location, or you can retrieve the data from the selected memory location through the data bus width of 4 bits. Next, in the third example, I have total 64 locations. So in order to select one of the memory location, so we require the address decoder with the order of 2 power 6. So where it requires total address bits are 6 address bits, which are started with A5, A4, A3, A2, A1 and A0. So it requires total address bits are 6 address bits are needed to select one of the memory location, but the data which is holded in each memory location is one data bit. So only one data bit is obtained from your each location. So like this, so these the order of the memory is classified based on your number of address bits as well as your number of data bits in your memory. So number of address bits can decide here how many number of locations are available in your memory, and the width of your data it will define the number of bits in each memory location which you can enter or which you can retrieve from a memory location. So the data which you can enter into the new data which is entered into the new memory location, selected memory location, is known as your memory write operation. The data which the method of your retrieving the data from a stored memory location is known as your memory read operation. Now, so based on your method of your entering the new data or retrieving the data from a memory, you have basically two classifications, RAM and ROM. So RAM is a random access memory, ROM is a read-only memory. RAM stores the new information for later purpose, and after processing your data, the new information again it will be stored into the memory, which is called as your write operation. So now read-only memory. So this read-only memory, it can perform only the read operation. It can't accept your new data to be entered into the memory. So hence it doesn't have your any control signal which can enable output devices data must be entered into the memory locations of your RAM. So only we can retrieve the data. So it can have only the control input, which is a read control input. It doesn't have your write control input. But in your programmable read-only memory, which is one of the example of your programmable logical devices, so where you can program only, you can program once. So once if you have programmed, so that will be fixed, and you can retrieve the data, and you don't have the opportunity to reprogram your prompt. So in your prompt, so you can have your the fuses which are intact. So there is a method of hardware. So we are going to use a method of hardware techniques for programming your read-only memory. So in that programming, so programming involves blowing the fuses which holds your logical 0, intact fuses which holds your logical 1. So once you load the data, you can't, once you blown that switch or blown that fuses, you can't intact your fuses. So it will be permanent. So then we can obtain your data from its memory location by storing the logical ones or by storing the logical 0. So blown fuse indicates the logical 0 and intact fuse indicates your logical 1. So initially all the fuses are in intact position. So each memory location are holding all memory locations are holding your data bits of 1. But when you wanted to program, so you have to blow that fuse When you blown the fuse, it holds the 0. Once you blown the fuse, it should not be again reprogrammed. So the method of your blowing the fuses is known as your programming. Now here, based on this, so we have three techniques of programming your fuses, so which are comes under your PLDs. So those are programmable read-only memory, your PAL and PLA. So PAL is your programmable array logic and the PLA is your programmable logic array. So along with this, we also have your field programmable gate arrays. So where you can have your an array of your AND array as well as your OR arrays, both are programmable. Now in that programmable logical devices, so you have your fuses intact. So blowing the fuses along with the path can remove your the previous stored logical 1 bit, and based on your particular configuration you can obtain your logic of or implement your required logical functions. So now these PLDs can have your an array of your million number of or you can have your 1000 number of your AND arrays or your OR arrays, where these AND arrays and OR arrays are connected. So internally you will also have your some interconnections, so which are with the internal paths, and the programming can allow your intact fuse or blown fuse can connect your inputs, so multiple number of inputs. So now for simplification of your logical symbols of multiple input OR gate, so we can provide only one horizontal line with a vertical line. So these vertical lines indicates your programmable inputs which are connected to the OR gate input. In the same manner, you can also read here for the multiple input AND gate, so with only one single input. So by drawing that, so perpendicular lines, you can have your the inputs which are connected onto the programmable AND gates. So using this technique of your programming, you can retrieve or you can obtain your the required logical functions from this PLDs. So in coming session, how to retrieve those or how to derive those programmable logical devices and how to obtain the required functions, that we are going to see in your coming sessions of PLDs.